Good morning. Welcome to today's discussion. We're going to cover weather brief. We're going to get into weight and balance, and we're getting into an emergency descent or how to fly the emergency descent. Let's get to it. First, let's switch over to our weather brief here. All right, starting from the top, here's your table of contents. I filed or I requested a weather brief for Payne down to Olympia today. All right, starting from the top, we have no temporary flight restrictions. We have no closed or unsafe NOTAMs. Oh, correction, we do have runway 16.34 right is closed except for crossing traffic on May 1st or April 30th, 1900 local until April 30th at 2100 local or 2059 local. Destination Olympia, none. Alternate Arlington and Skagit, none. No convective segments, no segments. No IFR air mats. Oh, actually, we do have a mountain obscuration air mat. Remember that mountain obscuration air mat doesn't necessarily ground us. It just tells us that there are clouds low enough to obscure mountains. Let's see, mountain obscuration. Anything else? Here's our freezing level, 8,000 feet out here, 8,000 feet over here, between 6,000 and 9,000 here. No turbulence or low altitude, turbulence, high altitude, no strong surface winds, no low level wind shear, no urgent PIRAPs, no center weather advisories, no severe weather, and no volcanic ash. Awesome. Looking at our synopsis, we have a trough off the east side of the country, or out of the east side of the state, eastern Washington, low pressure system, and that elongated area of low pressure, that's called a trough. Looking around the rest of the country, we have that cold front moving south on the east coast. We have a warm front moving up through Texas and a dry line off to the west side of Texas here. That tells us that there's relatively dry air on the west side and moist air on the east. Cold front moving from west to east. A couple of high pressure areas here, trough, low pressure, and some precipitation. And remember that these are called isobars. Looking down at our METAR, it's all blue. Looks like it's all marginal today around the Puget Sound. We've got marginal conditions at Payne, wind 160 at 8 knots, 10 miles visibility, and the ceiling is overcast at 1,800 feet. The temperature is 8 dew points 4, and the altimeter is 30.03. Recall that the dew point is the point at which air becomes saturated with moisture, so you're likely to see low-level clouds if the temperature and the dew point are really close together. Today, they're about 4 degrees off. And of course, you can practice interpreting all these METARs on your own. We're going to go run through this real quick. PIREPs, we have negative turbulence on both of these PIREPs here. And if we want to get more in depth, over Payne on this 180 radial at 2 nautical miles at 829 local. The altitude is 1,400 feet in a Cirrus SR-22. The sky conditions were reported at 2,000 feet, and the remarks were the bases were near 2,000 feet. And over the Seattle Tacoma International Airport on the 340 radial at 6 nautical miles at 1539 Zulu or 839 local. The altitude was 2,400 feet. The aircraft was a Boeing 737-900, and the sky conditions were bases at 2,400 feet with remarks during descent, final approach, runway 16 right. Here's our flight category. Looks like for the next 4 hours, it's going to be marginal with some low IFR and IFR conditions off to the east. The ceiling is going to stay pretty low, around 2,000 to 3,000 feet. What else? What else? Visibility is going to be pretty good all day, except a couple of pockets off to the east over here. Looks like, yeah, less than a mile of visibility. Cloud cover, it's going to get cloudier the further south we go, and it looks like it's going to pretty much stay the same throughout the day. Cloud top, same deal. We'll keep moving on here. Thunder coverage, ooh, a little bit. Oh, that's precipitation, excuse me. Precipitation off to the northwest. And here's thunder coverage, none. That's what I like to see. Winds about 5 knots from the west. Cool. Surface winds, 5 knots from the south. Not too bad. And of course, remember that these are in hour increments. So at 1600 Zulu, 1700, 1800, and 1900 Zulu. Surface wind, same deal. More surface winds. The freezing level is going to be around 7,000 to 9,000 feet. And yeah, it'll pretty much stay the same all day. The TAF, or the Terminal Aerodrome Forecast, will tell us that it looks like it's going to be marginal for most of the day. It'll clear up to about a 5,000 foot ceiling around 4 o'clock local and go back to marginal. Cool. Winds aloft. This is the wind direction and velocity at different altitudes. At 3,000 feet, the winds will be 230 at 7 knots. And you can see as we go higher in altitude, it'll get colder. 2 degrees Celsius, 0, freezing at 7,000 feet, -3 at 9,000, -8 at 12,000. Convective outlook. There's a general risk of thunderstorm activity in the orange, and it's going to get up to slight, from marginal to slight over here. NOTAMs, or notices to air missions. The ILS 16 right at Payne is unserviceable. There's an obstruction. Looks like zero point 0.6 nautical miles east northeast of Payne, 57 feet above the ground level. If you're flying that low, you've got other problems. But it is good to know that there are obstructions around the field that didn't make it into the publications. Canmore Air Harbor, same thing, 180 feet above ground level, zero point 0.5 nautical miles southeast of the air harbor. And you can read these at your own, but yeah, good to know. More destination NOTAMs. The VOR ground receiver checkpoint is unserviceable at Olympia, and the navigation ILS runway 17 glide path is unserviceable on April 10th at 8:20 local until 1 o'clock on June 26th, estimated. Cool. You can practice reading these NOTAMs on your own. So yeah, that covers our NOTAMs and weather. Let's go back to the actual presentation here and continue talking. All right, so that was our weather brief. Let's get into our weight and balance discussion. That's our main objective for today. We haven't covered weight and balance in a while, so I thought we'd talk about it. And then we're going to get into a maneuver, the emergency descent. All right, talking about weight and balance. What is it? We're going to talk about balancing the airplane within its approved limits. Why? Because this is critical for flight safety. Operating above the maximum weight limits compromises structural integrity and affects performance. And operating within the center of gravity or with the center of gravity outside of the approved limits can be very dangerous, adversely affecting flight performance and capabilities. We're going to go over some terms: weight and flight performance, weight and structure, stability and controllability, weight and balance control, and how to determine your weight and balance. So let's review some terms. You should be able to answer these pretty quick, so we're just going to get through them. What is the reference datum? That's the imaginary line from which all measurements of the arm are taken. So if we've got our little airplane here, some airplanes will have their reference be the tip of the prop or the firewall, right? Next, what is the arm? The arm is the horizontal distance from that reference datum line to the center of gravity of an item. What's the station? It's the location in the aircraft identified by a number designating distance from the datum. The moment. What is the moment? It is the weight multiplied by the arm of an item, usually expressed in pound inches. And that makes sense, right? If we have our little airplane here and we are measuring some distance in inches, and this is 39 inches, and we're multiplying it by our weight, let's say 150 pounds, that's going to give us some number in pound inches. And as an engineer, I really like doing unit analysis to verify that all my calculations make sense. So if you get in the habit of, looking at the units, that'll set you up for success. Next, what is the moment index? That's the moment divided by a constant, such as 100 or 1,000, to make it easier to work with. Because you're working with like 20,600 pound inches, it's easier to divide that by 1,000 and just say 26.5 pound inches. What is the center of gravity? That's the point at which an airplane would balance if suspended at that point. What are CG limits? Those are specified forward and aft points within which the CG must be located during flight. What is basic empty weight? That is the weight of the airplane, optional equipment, unusable fuel, and full fluids, so like oil. What is unusable fuel? That is fuel in the tanks that cannot be safely used in flight or drained on the ground. Fuel. So basically, if you look at your fuel tanks here, like there is always some amount of fuel that won't make it into the system because it's below the little lip here. And that's there for a purpose. Like that's there for a reason. You want to be able to have all of like water or sediment settled below where it feeds into the fuel system, so you're not feeding water into your engine. What is your maximum takeoff or landing weight? That's the greatest weight allowed for takeoff and landing. Pretty straightforward. What's your maximum ramp weight? That's the total permitted weight of a loaded aircraft, including all fuel. What's your maximum zero fuel weight? That is the maximum allowable weight, exclusive of usable fuel. What's your payload? That is the weight of the occupants, cargo, and baggage. Think like the space shuttle. What's the payload of the space shuttle? Right? That's all the stuff inside. What is the useful load of your aircraft? That is the basic empty weight subtracted from the maximum allowable gross weight. Here's some standard weights. What are these standard weights per gallon? Avgas is 6 pounds per gallon. Jet fuel is 6.8 pounds per gallon. Oil is 7.5 pounds per gallon. Is that per gallon? And water is 8.35 pounds. All right, let's talk about weight and flight performance. Now, if you ensuring that you're within your maximum takeoff and landing weights will ensure aircraft performance. Now, the higher your weight is, the harder it is for that aircraft to get off the ground. And once it is off the ground, if you make it off the ground, it'll be harder for it to climb out than it would if it was a little lighter within those weight and balance parameters. You're going to have a lower maximum altitude that you can climb to. You'll have a slower cruise speed, reduced range, and increased fuel consumption, reduced maneuverability. You'll have a higher stall speed, and you'll have a higher approach speed and a longer landing roll. You're going to have more mass, flying down the runway. So it's going to take you longer to come to a stop. It also might put excessive weight on the nose or tail wheel. Some effects of overloading: significantly degraded climb performance, a lower maximum altitude, overheating during climbs, and added engine wear, and overstressing the aircraft structure. Your flight performance degrades at higher weights and may not be possible if overloaded. This is important. If you have your aircraft overloaded, you might not ever get off the ground, and that would suck. You might fly into a tree or a fence at the end of the runway. Let's talk about how weight affects your structure. Uh, we've studied in engineering that failure can be a slow process. If you overload the aircraft once, you might not notice anything. But if you get in the habit of overloading your aircraft, that cycle of stress can build up and eventually wear down your aircraft structure. Yeah, so the habitual overloading can add up over time, leading to failure. You can also impose excessive G's or cabin weight. Here are the normal category, or here are the categories for certificated aircraft. For the normal category, your aircraft should be able to sustain between negative 0.52 and 3.8 Gs. In the utility category, between negative 1.76 up to 4.4 G. And in the acrobatic, you should be able to sustain negative 3 to 6 Gs. Now imagine if you are flying at, in the utility category, pulling 4 Gs, and you've overloaded the aircraft. You're putting a lot of stress onto that airframe. You should always follow the aircraft's or the manufacturer's guidelines and placards for your airplane. The airplane as a whole, as well as specific requirements for seats, baggage, and compartments and cabin floor. So basically, know your POH, understand how to do your weight and balance, and know how to stow everything inside the aircraft. It might not just be like, yeah, you can throw whatever you want in there. You should also like secure things the way they're supposed to be secured. Let's talk about stability and controllability. If your aircraft has a forward CG, or if you've loaded the aircraft too far forward, it'll feel heavier and slower. You will need a higher angle of attack to maintain altitude, making you have a higher stall speed, and it'll have a higher induced drag. Now, one kind of benefit of a more forward CG is that you'll have a more controllable stall. The aircraft will want to pitch down if you stall it, and that helps in a stall because you need to reduce that angle of attack. All right. the nose is going to be heavier. But the problem is you may not be able to hold your nose up at slower airspeeds like during landing. So if your CG is too far forward, the aircraft will want to nose down and it might be difficult to pitch up. Now, an aft CG, if your center of gravity is too far to the rear, if you've loaded everything in the trunk, your aircraft will feel lighter and and therefore be faster than an aircraft with a forward CG. You'll you will need a lower angle of attack to maintain altitude, leading to a lower stall speed and lower induced drag. Unfortunately, you'll have a less controllable stall because the aircraft is loaded to the rear. The plane will want to pitch up, so it'll make stall recovery a little harder. And of course, if your aircraft is laterally loaded, unbalanced, if you've got way more stuff on one wing than the other, that's going to make things really funky. It's going to be unbalanced and can lead to more drag or increased drag and decreased efficiency. Here's some regulations for you. 14 CFR Part 23.21 requires that the manufacturer determine safe CG limits, and Part 91.9 requires you, the pilot in command, to comply with those operating limitations. You must ensure your current weight and balance information is up to date, and if you change anything in your aircraft, like adding new avionics, that is accounted for with a new weight and balance sheet that the mechanic, goes and weighs and balances the plane. And you must do your calculations prior to every flight. Every time you fly with me, you'll see me ask, hey, how much do you weigh? I'm going to plug it into my Excel spreadsheet that I've created to make it super quick. And you should be doing these calculations as well. You need to determine your weight and balance and ensure that it's within the manufacturer's limitations. And if it's not, what are you going to do? Well, we'll shift some things around, remove some weight to make sure that we are flying safe. Now, how do we determine our weight and balance? Now, the basic equation is the sum of the weights. Sorry, back it up. We're going to take the sum of the weights, so everything inside the aircraft, and we're going to take the sum of the moments, that is the weight times the arm, and we're going to divide the two. So the pound inches divided by pounds, that's going to leave us with inches. And that's going to be, in reference to that data, that reference line. Okay. So I like to do this: item, weight, arm, moment. Make a little grid or Excel spreadsheet. Let's say the aircraft, the pilot, bags, and fuel, right? So we're going to take the weight of the aircraft. That's usually going to be given on your weight and balance sheet, and they're going to give you the moment. So that's going to be some number. Again, remember this is in pound inches. We're going to take the weight of the pilot, let's say 180 pounds, times the arm or the distance from that reference line, let's say 39 inches, and that'll give you a number in pound inches. Same thing for your baggage. You want to determine, what the distance from that reference line is, and that's going to be in the POH. And the fuel, remember that fuel is 6 pounds per gallon. So let's say you've got 20 gallons, you're going to multiply that by 6. And you're going to multiply that times the arm for the fuel and get your moment. You're going to take the sum of those moments in pound inches. And you're going to take the sum of those weights in pounds. And we're going to divide them. Sum of the weights here, the pounds will cross out, and we'll be left with a value of inches. Remember that I like unit analysis because that ensures that I'm getting a reasonable answer. So once you determine that, your center of gravity will be in inches, and that's distance from that reference line. And then you're going to go in your POH and make sure that that center of gravity is within the envelope that is safe. And some POHs will actually give it to you in the moment and not in the center of gravity. So just be aware what units you're working with. If the chart says, weight versus inches, that's center of gravity. If it says weight versus pound inches or moment, that is the moment. So just be mindful, make sure you're using the right units. Questions? No? Awesome. Let's move on to emergency descents. What is this? This is a maneuver for descending as rapidly as possible to a lower altitude to the ground for an emergency landing. So why? The need for this maneuver may result from an uncontrollable fire, a sudden loss of cabin pressurization, or any other situation demanding an immediate and rapid descent for survival, like one of your passengers is choking on a ham sandwich, and we need to get him down to a medic or whatever. We'll talk about the basics and how to perform an emergency descent. The objective of this is to descend as soon and as rapidly as possible within the structural limitations of the airplane. You can't just do a split S and dive down, to the ground in your little Cessna 172. You have to be careful. So, some situations that may necessitate an emergency descent are a fire, smoke, or loss of cabin pressurization, or anything else demanding a descent, such as a medical emergency or an injury. So prior to the maneuver, we'll run through our pre-maneuver checklist and clear the area. We'll select a safe altitude and airspeed. We're going to reduce our power to idle. If your POH recommends it, we'll extend flaps and landing gear as specified by the manufacturer. This provide drag to increase the rate of descent without excessive airspeed. Your flaps are really useful for descending rapidly without increasing your airspeed unnecessarily. You're going to lower your nose to maintain the maximum allowable airspeed based on the procedure. Obviously, if you've got your flaps out, you're going to want to maintain at or below your maximum flap extended speed. All right. Your speed can vary based on your flap settings, the nature of the emergency, and turbulent conditions. Never exceed your VNE or your VFE. In the case of turbulence, do not exceed your VA. As the nose is lowered, begin a 90-degree turn to the left at between 30 to 45 degrees of bank. This puts positive load on the aircraft, countering the negative load from the descent, and acts as a clearing turn, so you can look down below and to the side. This gets the airplane off the airway you might have been on, and the left turn is faster because if you've got other aircraft, they will be passing. If you've got faster aircraft, they'll be passing on the right. Now, your level off should be smooth to prevent overstressing the airplane. You don't want to just yank back on the yoke, right? Just like before when we were doing basic maneuvers, you can use the 10% rule. So you can lead the level off by 10% of your vertical speed. So if you're descending at 1,500 feet per minute rate of descent, you can level off 150 feet above your target altitude. Now, this will vary by the aircraft demand and performance capabilities. In the event of a real life emergency descent, do what you got to do to land safely and stay alive, right? You want to increase power to the cruise setting or as required. Once you're straight and level and accelerating, return to the normal configuration. Bring your flaps up in gear. And remember not to exceed your maximum flap extended speed, right? And then you want to trim the aircraft and adjust the mix. Bam. And that's your emergency descent. Remember, that is for emergencies. And of course, you want to demonstrate it on the check ride. So flaps out, 30 to 45 degree bank, descend down to your target altitude, lead off your level off by 10% of your rate of descent, and then keep an eye on your airspeed, and then level off, return to straight and level flight, bring your flaps up, and continue on your merry way. Or land, of course. Bam. And that's the emergency descent. Sweet. All right, if there are no other questions, we'll call it a day. Thanks for hanging out.